Question 2 from the midterm asked us to show the reaction with complete mechanism that occurs when the following imine is exposed to water under acidic conditions. So the first thing we would like to do is just put the conditions on our arrow so that we're going to remember what we have. As we've discussed in class, almost always the first step for a reaction under acidic conditions is to protonate something. In this case, we're going to protonate our nitrogen. That's really the only site that we could potentially protonate. So we protonate our iminium nitrogen. And what we've done now is we've taken an imine which has a slightly electrophilic carbon right there, and we've activated it so that now it has a positive charge and it becomes a very good electrophile, and it can now react with a weak nucleophile such as water. So now we bring in our water molecule. We realize that we have lots of water, so we don't have to worry whenever we need water. We realize that it's there. Water acts as the nucleophile and attacks the iminium carbon, and we can promote a pair of electrons up to the nitrogen. And at this point, we realize that we have a compound, and what can this compound do? Well, it could lose water, in which case it just goes backwards. And we know that these reactions are under equilibrium conditions. What else can we do? We have lots of water around, and we had some acid. Water can act as a nucleophile, can also act as a base. So in this case, we're going to use water to act as a base and remove one of these protons. We're going to remove one of the more acidic protons. Why are we doing this? Well, we realize that we need the proton somewhere else in order for this reaction to go forward and not backwards. So our next compound, once we've deprotonated, looks like an alcohol. And now we recall that we have a lone pair of electrons. We've now also formed hydronium, which is our acid, and we can use that to protonate the molecule. If we protonate the oxygen, we just go backwards. So we're going to protonate the nitrogen. Once we protonate that nitrogen, we see that we have an amine functionality, and if we just break that carbon-nitrogen bond, we free up that amine functionality. So we're going to push the electrons off. We're going to use the lone pair of electrons on our alcoholic oxygen to push off and break that nitrogen-carbon bond. We do that, we end up with this species, and we realize this species is simply a protonated carbonyl functionality now, and we have, again, lots of water, and we can use that to remove that final proton. Couple things about this reaction. You'll notice that I specifically showed my water acting as a base to remove the proton. I would certainly accept in this step if you simply said minus H plus here, or if you told me that you were removing a proton. Because I asked for the complete mechanism, I wanted to see everything, but we could also indicate that we're having our proton shift from the oxygen to the nitrogen through a series of proton transfers that gets us to this species. This is the species we need to be able to break that carbon-nitrogen bond and come up with our protonated carbonyl compound with an amine in this position. And finally, we just deprotonate the final product, the final protonated species, to get our final product. We've reformed our acid. So we reacted this imine with water under acidic conditions. We've added the elements of water, and we regenerated our acid catalyst.